Hello, everyone. My name is Andy Wang. I'm the Dean of the College of Engineering, Informatics, and Applied Sciences. On behalf of the college, welcome and congratulations to all of you on being admitted to this prestigious university. This is a unique college where we offer forward-looking programs of study. We offer plenty of opportunities to engage in research across campus and with industry partners. When you come here, you will make new friends, connect with student club and organizations, bond with the college faculty, obtain information about scholarship and tuition assistance, building personal and professional network and friendship that extend well beyond your graduation. Your success starts here. Today, I'm honored to introduce Dr. John Tingerthal, Professor and Associate Chair of Civil Engineering, Construction Management, and Environmental Engineering Department. Dr. Tingerthal is NAU President's Distinguished Teaching Fellow. Through his lecture today, you will have a taste of what construction management class look like. Thank you.
Thank you, Dean Wang. I'm going to share with you a sample from my structural analysis class. This is an example from 2021 when we were teaching online. However, many of the techniques that you'll see here are techniques that we use in the face-to-face classroom. For instance, many of the faculty in engineering use tablet PCs where we project our screen in the classroom and we're able to save what we do so students can look at it later. We also use interactive questioning and answering and live demos. What you're going to see are some clips from an actual class on structural stability. Stability, of course, is fundamental to mechanics, and we see it in construction management, we see it in mechanical engineering, and civil engineering courses. So let's join this class in progress.
So, stability. I want you to be thinking about this one question. What is the difference between stability and strength? Okay, that's kind of a prompt. But let me talk a little bit about stability here first. And I think the easiest way to think about stability, let's not look at our tower here, let's just think about okay, let's say we've got this little hill here and we have a marble. Okay, so we have this little round marble sitting at the bottom of a hill. Okay, now is this stable? Meaning, is this marble in a stable position? Yes or no? Go ahead and throw it in the chat. Yes or no? Is that stable? Okay, so I'm getting lots of yeses. How do you know it's stable? What tells you it's stable? Why do you know that that's stable? It's holding, right? It's not moving. Okay, so let me give you the counter example here. This is another marble sitting on a hill this time. And this one is sitting there. It's not moving. So the answer that I saw Josiah and Lucas say is it not moving. That one's not moving either. But is this one stable? Now I'm getting different answers. I'm getting yes and I'm getting no. Okay. So Elijah said can't move without outside force, but it wouldn't take much outside force. Jessica's got it, I think. The slope holds the ball in place. Depends on conditions. Okay, so let's just think of it this way. Here's the real thing to think about is if I was to give it a little bit of a force, right? So Elijah says can't move without an outside force. So let's give this blue ball a little bit of a force. Let's take our hand and push it. Okay, so it starts out here and it moves to position 2. So we move it to position 2. And I let go of it. What's obviously going to happen? It's going to return, right? And as we know from physics, it'll oscillate, right? So it'll come back, it'll overshoot, and it will return to original position. Okay, so if moved, and the idea is slightly, because I mean I could move it up to the end here and it could fall off, right? So we're not thinking about that, okay? We're just thinking about a slight movement. It'll come back to its original position. And that is really this definition of stability. Okay, so stable. S-T-A-B-L-E, I can't spell stable. Okay, so what happens to the red ball if I give it a little bit of a movement? So it starts in position 1, I move it to position 2, yeah, it'll keep going, right? It'll roll down. So position 3 is out here. Okay, so this is unstable. And by definition, unstable would be if, I'll try to improve my handwriting here, if moved slightly, okay, will continue to move in that direction, let's say. Okay, so there's your basic concept of stability and instability, right? So in a structure, basically, the idea is progressive collapse, okay? So you have a structure that you move, give it a little bit of a movement. You put a little wind on it, someone bumps into it, something like that, it will move and keep going, right? Okay, so let's go back to my blocks here, right? And what happens if I give this thing a little bit of a push, right? So I come into this thing, and if I give it a little push, seems like it's okay, right? And it really depends on where I push it from. I could give it a push at the bottom, and it slides, but that seems relatively stable. But in general, if I give this thing a push, okay, because the blocks are just stacked, it's not doing too well, okay? So that's something that's unstable, right? Okay. Stack her back up here. So here's my question to you, okay? My question to you is, what can you do to stabilize that thing? You've got this stack of blocks, and let's just not think anything more than a stack of blocks. There's different ways of stabilizing this. So what I'd like you to do is I'm going to create a bunch of breakout rooms. Show you where this is. So there'll be this thing called collaboration space, and there's a stability, and I just created a whole bunch of copies of the exact same thing, 1 through 20. I'll make a bunch of great breakout rooms, and you should be able to just sketch directly on those. So let me create a breakout group. We'll do 5 minutes, and I want you to come up with as creative of a solution as you can to stabilize this structure.
Students at this point in the live classroom would be given a bunch of blocks, and they'd be actually working together to build these out.
So what I'm going to share here is the, should be able to see on the screen, some of the ideas you came up with. I'll go just one at a time just to look at the different ideas here. And if someone who worked on one of these groups wants to chime in with your ideas, please do. So the first one, drive a nail through the stack. Perfect idea. Again, the idea that we could, drill a hole down the middle and put one giant nail through the middle would really be helpful. Here's the second one. Second one, I see some guy wires coming down. I'm not sure what the little green box is in the back. Maybe it's reconfiguring the block. So I'm going to add that. So the idea of providing lateral stability to this thing is really what we're looking at. Now, the drawback of this one is you know, if you don't have those wires tight enough, you might be able to slide some of the blocks out from underneath. Here, have a central column. That one looks pretty similar to the one with the nail in it. So I like that one. This one's a belt and suspenders, right? Someone want to tell me what the blue represents?
Yeah, so we did like the bottom is like little like an L bracket like secured to the bottom surface and like the bottom block so the bottom wouldn't slide or move, and then up the side just like a straight bracket to hold the blocks together.
Okay. So you've connected them, and then you've provided a bracket at the bottom, and then you have these nice diagonal stays like you would have on a radio tower at the corner. Cool.
So at this point, I would go through and walk through all the different breakout rooms and talk through the different solutions that the students came up with. And we'd compare them, contrast them with each other, and then we'll get to the point where we wrap up the lecture.
So to close off, I just want to have you think about this a little bit. I want you to think about this difference between stability and strength. So for instance, my blocks of wood over here are pretty strong, right? If we think about it, let me see if I can share that camera again. Okay. So I can take this block, this block of wood here, move my camera back a little bit, and I could stand on this, right? I mean, if I take this thing, put it on the ground, put the camera on the ground, hopefully you're able to see it here, and the strength of this column is pretty good. I'm going to put my weight on it. Would you do this? No, don't try this at home. And it holds my weight, right? That's good and strong. But the difference between strength and stability is this thing can hold my weight. I could probably put 4 people on this. The blocks of wood, pretty strong. But stability, a little bit of side movement, and it's not very safe.
That was just a sample of the type of teaching you can expect in engineering at NAU. We look forward to seeing you in the classroom.